What's up everyone, Patrick here, welcome back, and in this video what we're going to do is we're going to find the union and intersection of these sets here. So notice that these are three separate questions. So starting with number one, we got set A, which is x is an element of real numbers such that x is less than 2, and then we have x is an element of real numbers for set B such that x is greater than or equal to -1. Now one thing I want to mention is when you're dealing with real numbers, you can actually lots of times take these sets and put them in interval notation like this. And these specific sets, we can do that. Notice that all the real numbers that are less than 2, what we can do, we can rewrite this as from -infinity to +2, like that. Right? This and this, they're the exact same thing. They're just in different notation. We could take this and we can write it as from -1 inclusive of the -1. So there's a square bracket to +infinity like that. Right? So these are the same sets. And then same thing with these. We could take these and put it in this kind of notation. So you should be pretty comfortable in being able to switch notations because you never know if it's a multiple choice question. Sometimes the answer will be given in this format, sometimes it'll be given in this format. So you got to be able to stay flexible. And then once it's in this format, personally, I like this format better. It's easy to see what the union and intersection is. In fact, you could even show this on a diagram too, on a number line. So if we got 0 over here, we got -infinity, +infinity. This set here, we're going to go from -1. It's inclusive of the -1, so that's going to be a solid dot, to +infinity. And then this set here from -infinity to 2, you're always reading from left to right when you're looking at these intervals. So from -infinity to +2, so +2 would be here, not inclusive of the 2, so that's an open dot, right? It's not inclusive of the 2, and that's going to go like that. And then just from this diagram here, it's easy to see what's the union, what's the intersection. I'm going to start with the intersection between them. Usually I start with that, the more restrictive case. And so what's common between these two sets? What values are common? Well, notice that it's all of these numbers over here. That's what's common in both of these, right? So the intersection is going to be from -1 inclusive of the -1 to 2, but not inclusive of the 2, like that. So the 2, it is in set B, right? But it's not in set A. So we wouldn't include that, but -1, notice how it's in both sets. And then anything outside of those is not going to be in A and B, right? The intersection, it has to be in both of them. Now the union's actually really easy because it's basically, it has to be in A or B, and with A or B, notice all of the numbers are included, right? Goes all the way from -infinity all the way to +infinity. So there's no numbers that are left out in this set. You could see it in this diagram on the number line, right? So 2 is left out in set A. Actually, all the numbers that are greater than 2, greater than or equal to 2 are left out in set A, but they're in set B. Set B, all the numbers that are less than -1 are left out, but they are in set A. Right? So anything that's left out from one set, it's in the other. And so if you're looking at A or B, it'd be -infinity to +infinity. But the intersection is from -1 inclusive of the -1 to 2. And I'm going to leave the answers in this format, but these answers, they could also be in this format. So just be careful, again, on a multiple choice tests. Moving on to number 2. Notice these are already in interval notation, so we got negative infinity to 0. So let's draw it over here. We got 0, negative infinity to 0. So that's inclusive. And then, sorry, it's not inclusive of the 0. So that's set A right there. And then set B is from 0 to positive infinity. It's not inclusive of the 0 over here as well. So both of these are open dots here at the 0. And so notice, what's the intersection between these two? Notice that they don't have anything in common, right? There's no lines that overlap with both of these sets here, right? The 0 is not in both of them. And so the intersection between these two, it's actually just an empty set or a null set. So you could put brackets with nothing there, or you could represent it as 0 with a slash through it. Right? And then what is the union? What's an A or B? Well, it's going to be from negative infinity to 0, or from 0 to positive infinity, like that. Right? 0 is not included in either or. So there's like this break here. If you remember from functions in high school, it's kind of almost like a vertical asymptote, right? It's not defined there, so we have to break that domain, right? We're working with sets here, but it's a little bit similar. So from negative infinity to 0, not inclusive of the 0, and then from 0 to positive infinity like that. Now, let's say that this here was a square bracket. You may want to add that maybe as an extra question in your notes. If this was a square bracket, then this would be inclusive. And then this union here, this A or B, it would change to negative infinity to positive infinity, because now that 0 would be included in this set. And so when you look at both sets, all the numbers would be included in this union set here. But because this was a circle bracket, 0 is not included in either. And so that means that 0 is not included in the union. Right? So that would be the union, and then that would be the intersection. It would just be the null set. And then finally, number 3. So let's take this and draw it out. So we got negative 5 to 2 for A. So if we got 0 over here, we'll start at negative 5. We'll go to 2. Give me a sec here. You know what? Let's space this out. So I'm going to put 2 over here. So we're going from negative 5 inclusive of negative 5 to 2 but not inclusive of the 2. So that's this set. And then this set, we're going from 1 to 6. So we're going to go from 1, that's over here, inclusive of the 1, to 6, that's an open dot, and that would be right there. Like that. Right? Yeah, it looks good to me. So these two sets, these are the sets shown on a number line here. And so let's start with the intersection. What's common in both of these? Well, what's common is this area over here, right? All these values over here. So notice that 1, it's common in both. And then it goes to 2, but 2 is not in set A. It is in set B, but it's not in set A. It's got to be in both for the intersection. So it ends just at 2 over here. So that would be a circle bracket like that. right? These values here, all the values from -1, inclusive of -1 to 2, but not inclusive of the 2 because it's not in set A, that would be the intersection for these over here. And then what would be the union? Well, the union would be A or B, and so it would actually be from here all the way to there, right? So it would be the left boundary or the left endpoint of set A all the way to the right boundary or the right endpoint of set B. So it would go from -5, inclusive of the -5, to +6, but not inclusive of the 6. There's a hole there for set B, and then there's no 6 in set A, right? So it would just not be inclusive right there. So it's basically all the numbers, A or B. What numbers are in A or B? Well, any numbers from -5, not inclusive of -5, to 6, and then what's in both of them, 1 to 2, inclusive of the 1, but not inclusive of the